Hi guys. So I am going to do 9.2 today again because I already did it and it didn't record. So yay, I'm going to do it again. So here we are, 9.2. Whoops. Going to zoom in. So make sure you title your page. We're going to be graphing parabolas. Y equals ax squared plus bx. I suggest that you pause the video and copy the key concept into your notes. I'm going to zoom in a little bit. Hopefully it's a little bit clear. Eyes aren't that clear anyways. So, properties of the graph of a quadratic function. So a quadratic function is a parabola. And you're going to get this parabola when you have an equation like this. If the coefficient in your leading term is greater than 1, it's going to be an up parabola, so a U shape. If you have a negative value, you're going to get a parabola upside down, so an upside down U. Also, depending on the value itself, if you have a number greater than 1, it's going to be more narrow. Anything less than 1, so absolute value, of course, it's going to be wider. So we're able to solve the axis of symmetry. So this is your axis of symmetry right here. And then this is a mirror image across this axis of symmetry. And we can solve it by using this formula. X is equal to negative b over 2a. Then once you figure out what that x value is, you plug it back into the equation and you get a y. And together they form the vertex. So we're going to do example 1. Example 1 gives us this equation. The first thing they want us to do is to find the axis of symmetry and then its vertex. And I'm going to switch over to my whiteboard. Have the problem ready. Zoom out a little bit. Let me move my picture. So it wants us to find the axis of symmetry and its vertex. Here's our equation. The first thing we're going to do is we're going to list everything. Let's list A, B, and C. So A is negative 2. B is 12. And then C is our constant at the end, which is negative 7. Also, when I look at my leading term right here, since it's negative, that's telling me my parabola is going to be upside down. Something you should do, that way you have a mental note of what this parabola would look like if you had to graph it. We don't have to graph it, doesn't say anything about graphing, just says we have to find our axis of symmetry and the vertex. So we're going to find our axis of symmetry. Axis of symmetry. So that formula is x is equal to negative b over 2a. In the book, it shows the negative in front of the equation. I'm sorry, in front of the fraction. Remember that negative could be applied to the numerator or to the denominator. It does not matter. They're all equal to each other. So now we're going to plug everything in. So we have negative because of the formula. The b is 12 over 2 times a. And then we start to simplify. So we have a negative 12 over 2 times a negative 2 gives us a negative 4. Once we simplify this fraction, we get our x is equal to a positive 3. So that's our first answer, our axis of symmetry, which is positive 3, our AOS. But now we want to find our vertex. So to find our vertex, we need an x and a y value. Well, we have the x. Our equation is set equal to y, so we're going to take our x value, plug it back into the equation, and we'll find our y. So we have y is equal to negative 2. We're going to replace the value of x with 3 squared plus 12 times 3 minus 7. And start simplifying. Remember, we always have to apply the exponent first. So negative 2 times 9 plus 36 minus 7. Then negative 2 times 9 gives us negative 18 plus 36 minus 7. So we get our y value equal to 11. Sorry, I went to check myself. So together, they form the vertex. So the first answer, our axis of symmetry is x is equal to 3. And then our vertex is that x value with our y value together, which is 3, negative 11. So those are our two answers for example 1. So now I'm going to put this to the side. I'm going to look for example 2. Go back to the book. So for example 2, it wants us to graph this time. So now we're going to graph the parabola. It says graph 3x squared minus 6x plus 2. So they give a whole bunch of steps. The first thing they want you to do is determine which way the parabola is facing. So again, we look at our leading term. Since it's a positive 3, we know it's going to be an upward facing parabola. Then we're going to find the axis of symmetry, plug that in, get our vertex, and then you can plot a few extra points to get a nice exact graph. So my number 2, I am doing on paper. I didn't have graph paper, so I improvised. So here we have our equation. So just like they did in the book, we look at our leading term. Since it's positive, we know our parabola is going to be facing upward. Now we're going to find our axis of symmetry. So let's write our equation. X equals negative b over 2a. And now let's list our a, b, and c values. So our a is equal to positive 3. Our b is equal to a negative 6. Our c value is equal to a positive 2. Now we can plug it into our equation. Negative because of the formula. B is negative 6. Don't think it's negative. Don't forget there's 2 negatives there. And then we have 2 times our a value is 3. And then we simplify. A negative and a negative is a positive. And then that simplifies to where x is equal to 1. So we have our axis of symmetry. That's our AOS. So we're going to graph it. We're going to go to where x is equal to 1, which is right here. We're going to draw this little dashed line. It's not really part of the graph, but that means it's our middle part of our parabola. So now with that x value, we're going to plug it back into our original equation and solve for our y, and together it's our vertex. So we have y is equal to 3 times 1 squared minus 6 times 1 plus 2. Apply that exponent first. Well, 1 times 1 is 1. 3 times 1 is 3. Negative 6 times 1 is negative 6 plus 2. 3 minus 6 is negative 3 plus 2. We get our y value equal to negative 1. Together, they make our vertex, which is an ordered pair, so 1, negative 1. So we're going to plot that point. 1, negative 1, right here. So we know our parabola is facing up. So this is our minimum, which we're going to talk about next. So after that, we need another point so we can plot it and then reflect it across our axis of symmetry. So when we go back to our equation, just like in slope-intercept form, this constant is our y-intercept. So we're going to plot that right on y. Y is equal to positive 2. So 1, 2. Then once you have that point, we can reflect it across that axis of symmetry. Well, this is one space away from the axis of symmetry on the y, where y is equal to 2. So staying right there where y is equal to 2, I'm going to reflect it. So from the axis of symmetry, I'm going to go one space away. So it's reflected across the axis of symmetry. If you want to get another point, 2 more points, so we have a nice exact parabola, in the book, they do where y is equal to 2, we have that, and where x is equal to -1. So they plug in -1 just to get a point a little bit further away, and then they reflect it. So where x is equal to -1, when you plug it back into the equation, we get that y, not -1, yeah, y is equal to 11. So where x is equal to -1, y is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's a point. So that point is 1, 2 spaces away. So I'm going to keep going in that direction. 1, 2 spaces away. And it's reflected across the axis of symmetry. So we can get a better idea of what our parabola, looks like. So we have this parabola. It's not so pretty. I didn't draw it very nice. Kind of lost myself right there. So that's graphing. To review, you find your axis of symmetry first, take that x value, plug it back into the equation, solve for your y. Together they make your vertex. Dot your axis of symmetry so you know it's going to be a reflection across that line. Plot your vertex. If you want to get another point, pick another point on the x-axis, plug it into the equation, and then plot your y-intercept and reflect that across your axis of symmetry. So that's example 2. Go back to the book. So now we're talking about maximum and minimums. I suggest that you pause, copy this into your notes. It's another key concept. So when you have your parabola facing up like this, like a U, you're going to have a minimum. And the minimum is represented as your vertex. When you have a parabola facing upside down, where you would have, where A would be a negative value, you're going to have a maximum. And that represents its vertex. So for example 3, zoom in a little bit. So it says, tell whether the function, and it gives us this equation, has a minimum or a maximum value. Now we're going to go to our whiteboard, which I have here. Straighten out. So example 3 says, find the minimum or maximum value. So by looking at our leading coefficient, it's negative. So that's telling me my parabola is going to be upside down. So I automatically know we are going to have a maximum. Maximum because it's at the top. So I'm going to write that, maximum. And I know that's telling me I need to find my vertex. So the first thing I'm going to do is find our axis of symmetry. Write the equation. X is equal to negative b over 2a. Let's list everything. Our a value is negative 3. Our b value is negative 12. And then our c value is a positive 10. We're going to plug our values into the x equation. So we have negative because of the formula. B is negative 12 over 2 times a. And then we simplify. A negative and a negative gives us a positive. 2 times negative 3 is negative 6. So we have x is equal to negative 2. So that's our first part. X is equal to negative 2. So now we're going to take that value, plug it back into our equation. Well, don't forget, f of x is equal to y, foxy. F of x is equal to y, foxy. So we can find our y value. So y is equal to negative 3. Replace the value of x with negative 2. Negative 2 squared minus 12 times -2 plus 10. Apply that exponent first. A -2 times a -2 gives us a +4. A negative and a negative gives us a positive. 12 times 2 is 24 plus 10. -3 times 4 gives us -12 plus 24 plus 10. Keep going. -12 plus 24 is 12 plus 10. And then the last one is 12 plus 10, which is 22. We have y is equal to 22. So our maximum value, the vertex is -2, 22. That was example 3. I'm going to do one extra. So we found a maximum, now we're going to find a minimum. So again, by looking at our leading coefficient, since it's positive, that's telling me my parabola is facing up. So let's write our equation. So it's a minimum write our equation. X is equal to -b over 2a. Let's list our a, b, and c. A is equal to 2. B is equal to -16. And then our c is equal to 4. And take our values and plug it in. Negative because of the formula, b is -16 over 2 times a. A negative and a negative gives us a positive. 2 times 2 is 4. And then that simplifies to 4. So we have our first part. X equals 4. Foxy, f of x equals y. So we have y equals, replace the value of x with what we found. So 2 times 4 squared minus 16 times 4 plus 4. Apply our exponent first. 4 times 4 is 16. -16 times 4 is -64 plus 4. 2 times 16. I'm going to cheat and use my calculator. 32, yeah. So 32 minus 64 plus 4. 32 minus 64 is -32 plus 4. Then y is equal to -28. Don't forget, together it's our vertex and it's a minimum. 4 comma -28. So that is 9.2, graphing parabolas. Bye guys, don't forget to do homework 9.1 and 9.2.